right? The amount of hydrogen atoms for doing the same thing. I'm going to change everything to 15 unit hydrogen atoms in mole of this. Now, once again, I'm going to treat this question like it's a new question that doesn't relate to the previous one, just because you do need to be able to do this from scratch. If the question asks you to find the amount of hydrogen atoms in mole, that's just another way of saying we need to find N of H, and you are provided with the number of H2O molecules. So there is a little bit of inconsistent symbols here. We're given the number of H2O, but we need the number of mole of H. So you definitely at one point need to convert from H2O to H. Now I'm going to do something slightly different from what I did in the previous part, which is when I found the number, in the previous part, I found the number of mole of H2O already. Now, if you already have the number of H2O, then you can find the number of mole of hydrogen by thinking about how many H2O is required to get how many hydrogen atoms is required to get a H2O, and the answer for that would be you need 2 hydrogen for every 1 water molecules. Therefore, the number of mole of hydrogen will be twice the number of mole of H2O. This is one way to do it, and you can use the answer from the previous part to just get to this final step. However, I'm going to use another method. Now, what I sometimes do if I have time after assessment when I was a student, I did have time quite often, is I will solve the question using one method and then I would use a second method to check my calculation, especially because it is calculation. If you use an actual alternative method, I found, have a higher chance of picking up the mistakes than just reading things off. Because if you just read your calculation again, it's actually quite difficult to pick up a mistake. I mean, it is still difficult for me to pick up mistakes now. And so I tend to just do the calculation a second time. Now, the second method is, it's very simple. I mean, you do the same thing. So you still use the 2-to-1 ratio between hydrogen atoms and H2O molecules. But in the second method, I'm going to find the number of hydrogen atoms first. So N of H is twice N of H2O if we follow the ratio, which is twice of this. So I would get 2 times 6.8 times 10 to the power of negative power of 15. So you get 1.36 times 10 to the power of 16. Now, and we're going to be very impressive and actually have unit everywhere. And now I'm going to go to find the number of mole, which is just the number of atoms over Avogadro's number. So we have 1.36 times 10 to the 16 divided by 6.02 times 10 to the 23, and I get, okay, it's another exercise in rounding out or rounding up. 1, 2, 3, 4, 5, 6, 7, 8. So 2.3 times 10 to the negative 8 mole. Okay, so feel free to use this method and then check that you get the same answer.